Assalamu alaikum. Dear viewers, in this video you will learn the basic and important steps to be followed while designing a beam in the SAP2000, means in structure analysis program 2000. If you are designing a beam, so the important steps will be discussed in this video. So as you can see, this is the main window of the SAP2000. When you open for the first time the SAP2000, so by default this window will open. So let's discuss the different steps to be followed while designing a beam in the SAP2000. So these are the different steps to be followed. First, you have to open a file and from the new model. From the file, you will, when you click on the file tab, this is the main window, and this here in the menu bar in the file tab, when you click, so from on the top this is a new model, so you have to click on this new model to draw your model. And after this is the first step. The second step, you have to define the materials. So where is the materials? When you open the SAP2000 and draw the model, so you have to go to the define. In the define, when you click on define, there are different options. One of them is the to define material. So first we draw a new model on the tab, from the file tab. So when we click on the new model, so now it is processing. Now the cursor is in active mode and processing the model. So when you click on new model, this window will open. So let's suppose we have to draw a beam, so we will click on the red only and will specify the number of grid lines in the X, Y and Z direction. Let's suppose we draw a simply supported beam, so you will say there are two grid lines in the X direction, in the Y direction 1 and the Z direction 1. The spacing between the grids is 120 inches in the X directions, 1 in the Y and 1 in the Z, and this is the first red line location X, Y and Z. So you will click OK. Now you can see. So let we have to change the background of the model area, working area. So we will go to the options and we'll go to display, then go to the background, and then we'll click on this black and we'll then click OK and OK. So now you can see the background has been changed from yellow to black. So this is the model that we have drawn for the beam. This is the one end and this is the second end. And now we have to define. The second step is, after drawing the model, you have to define the material. So you will go to the define, and in the define on the top, the first option is material. So from this you can select the material. Then the third step is you have to define the member sections. How the member section is, you are defining in the material. You will define the material. Either you are modeling the member as concrete or steel or some other materials. So then you have to define the member section. So in the define, just below the materials, the second option is the section properties. From the section you can select the section of the members. Then the fourth step is the load pattern. So the first, there are three main steps in the design. of any structure or structure members in the shape, first you have to do the pre-processing, which is for the modeling, then the second is the analysis, and the third is the post-processing. So these are the three main divisions that you have to do as a main steps, and they are then subdivided into these. The pre-processing means the modeling is subdivided into these steps. Analysis is simply you have to analyze, click on the run analysis, and in the post-processing you have to display the display options. There are different options to display the results after the analysis when you done for the members. So in the display you can see the shear force, bending moment, the values of the shear force and bending moment at any location on the members. So in the modeling, the fourth step is the load pattern. So when you the load pattern, when you define the material and section, then you have to uh, select and the load pattern. The load pattern is you have to click on the define menu, and in the define menu you can see this is the load pattern. Then you have to select the load pattern. The fifth step is load cases. As you can see, the load cases is just below the load patterns in the define tab menu in the menu bar. The sixth step is the load combinations. After selecting the load patterns, load cases, then you have to define the load combinations. As you are familiar that in the LRMD method of design, so 1.2 is dead load factor and the 1.6 is the load factor for the live load. So you have to define the combination, load combinations, how they are combined, because the analysis is done for the load combinations, not for the individual loads. The seventh step is after the loads you have to draw the frame or cable. So then you have to go to the draw tab in the menu bars and will draw. There are different options, so you can draw your member. And then the eighth step, in which you have to 1 2 3 4 5 6 7, and in the eighth step you have to assign the member sections. So you have to apply the member section to a specific members that you have defined the member sections here in third step. Now you have to apply to the members. Then the ninth step, you have to assign the joint restraints, mean the support conditions, simply supported, hinge supported, or fixed supported. You have to provide and assign the joint restraints. And then the 10th and the final step in the modeling pre-processing is the assigning of the load. When you draw the members, then you have to finally apply and assign the loads to the members. Either it is point load, or it is uniformly distributed load, or it is uniformly varying load, or a combination of these loads. So then you have to assign the loads. Once you draw the members, applying the member sections, performing all these steps, then the second category of the main steps is the analysis. Then you have to run the analysis, and for the analysis the shortcut is of F5. So then you can click on the analysis, and then in the analysis tab the option is run analysis. F5 is the shortcut key for the run analysis. So when you draw the members, apply the loads, then and the giant restraint you assign, and then you finally run the analysis. When you run the analysis, then the member has been analyzed, and then the final step is the display options, which is post processing. You can display all the shear force, bending moment diagrams, support reactions, and the deform shape of a member, and all the results related to the members you can get in the display options, and even you can print the final report of the member that has been analyzed and designed in the SAP2000. So this is a very powerful software for the analysis and design, and it has been invented by the CSI, Computer Instruction Incorporations, and this is a very easy software to be used for the analysis of simple structure to very complex structure and structure members. So if you have any questions in these steps, you can ask in the comment section, and thank you for watching this video.